Hey guys, welcome again to Fun with Maths. Here's a nice problem. M times M times M all over M plus M plus M is equal to 9. Find the value of M. So here's the solution. First, let's bring down the given equation. M times M times M all over M plus M plus M equals 9. Now for this, let's multiply our numerator. M times M times M, that is equal to M cubed all over. Let's add our denominator, M plus M plus M, that is 3M, then equals 9. So we have M cubed over 3M is equal to 9. Next is, we can multiply both sides by 3. So 3 times M cubed over 3M, we can cancel this. So we're left with M cubed over M equals 3 times 9, that is 27. Now for this, we know that there is a constant power of 1. Now, by following the rule of a power, we have a to the power of x over a to the power of y. That is also equal to a to the power of x minus y. So for this, we can write it as m to the power of 3 minus 1 equals 27. Now, m to the power of 3 minus 1, that is 2, equals 27. Next is, we can insert a square root both sides so that we can remove the square because it will cancel. So now it cancel, also the radical. So we're left with m equals this square root of 27, we can split this into square root of 9 times square root of 3. And this is m equals square root of 9, that is equal to positive negative 3. Then times or square root of 3. So for this, we can have two values of m. First is m is equal to positive 3 square root of 3. Other one is m is equal to negative 3 square root of 3. Now we can check if the values of m are correct. So using the original equation, m times m times m all over m plus m plus m equals 9. But for this, we can write it as m cubed over 3m equals 9. Then m cubed, replace it with this. Let's use this first. 3 square root of 3. So this is 3 square root of 3 all to the power of 3 all over 3 times 3 square root of 3 equals 9. Next, for this, we can separate with a power of 3. So 3 cubed times square root of 3 all to the power of 3 all over. Here we can multiply 3 times 3, that is 9 square root of 3 equals 9. Next is 3 cubed is equivalent to 27 times square root of 3 whole to the power of 3 all over 9 square root of 3 equals 9. Now we can use a parenthesis to separate. And then let's put power of 1 because that is constant. So now it's easier to divide. 27 divided by 9, that is 3. So 3 times square root of 3 whole to the power of 3. Here, since they have the same base, square root of 3 and then square root of 3, we can just subtract the power. So 3 minus 1 equals 9. And then 3 times square root of 3 whole to the power of 3 minus 1, that is 2, then equals 9. Now for this, we can cancel the square and the radical. So we're left with 3 times 3, and that is 9, equals 9. So they are equal. That means this value of m, 3 square root of 3 is correct. Now using this value of m, negative 3 square root of 3. So negative 3 square root of 3 whole to the power of 3 all over 3 times negative 3 square root of 3 equals 9. So same, for this we can separate with power of 3. So that is negative 3 whole to the power of 3 times square root of 3 whole to the power of 3 all over. Here we can multiply 3 times negative 3, that is negative 9 square root of 3 equals 9. So same for our denominator, let's separate with a parenthesis, and then let's put a power of 1 as a constant. So now negative 3 cubed, that is equal to negative 27 times square root of 3 whole to the power of 3 all over negative 9 times square root of 3 whole to the power of 1 equals 9. Now let's divide negative 27 divided by negative 9. That is equal to positive 3. So 3 times square root of 3 whole to the power of 3. Here, since there is a constant power of 1 and they have the same base, so let's just subtract 3 minus 1 equals 9. And then 3 times square root of 3 whole to the power of 3 minus 1, that is 2, equals 9. Now for this, we can cancel the square and the radical, so the remaining is 3. So 3 times 3, that is 9, equals 9. So they are equal. That means this value of m, negative 3 square root of 3, is also correct. And that's all for today. For more exciting videos, don't forget to like and subscribe to Fun with Maths.